Now we will take the next problem. In this problem we have a g2 of s, which is equal to s plus 1 divided by s square minus 5s plus 6. Now I will ask you to do it. Anyway, I will try to do it myself, but if you want to do it, please pause the video and do it and then compare whether you did it the right way. Remember, when I want to do this in the Matlab, I need to know what is numerator coefficients and denominator coefficients for algebraic method, where I am using TF function. So numerator and denominator, numerator is 1, 1. Okay, first let me write that in the, okay, let me comment this. Again, somebody was interested, then zeros can be null. Here it can be 1 space 2. Here it can be 10 or in the bracket 10. Both can be okay. Okay. I can delete this so that one line of code will help me solve the problem. It will still work. Okay. Fine. So now s minus 1, s minus 2. Now I can comment this. Okay. If I want to use algebraic form, I'll just copy this. You can type it again if you like to practice more. Now I write it as G2 because it's 2. Then let us come back to our equation. It is s plus 1 numerator, that is 1 comma, sorry, numerator is 1 and 1. So I write it as denominator is 1 minus 5 and 6. 1 minus 5 and 6. So now if I run this, I get the s plus 1, s square minus 5s plus 6 form. Okay, let me comment this. Now if I want to run it in this form, that is ZPK form, I need to rewrite my equation in the required form as I have already done here. Okay, remember the gain is not there, that means gain is 1. Rest pole is at s equal to 2 and 3. Then 0 is at s equal to minus 1, because s plus 1 equal to 0, which means s equal to minus 1. And gain is 1. So I am going to use this. So gain is 1 and zeros are at minus 1. Pole is at 2 comma 3 or 2 space 3. Now this will help us understand how to generate in different forms. In any form you like, you get the same transfer function but in different form. That's very important. Okay. Now let us go to the next. If in case of instead of G1, G2, I can also write it as H1, K1, whatever. So H of S generally used for feedback path. Remember it is 1 by s square minus 6. There is no term for s. So it will be, please try it on your own. Numerator will be 1. Denominator coefficient will be 1, 0, minus 6. For algebraic form. Similarly, try what are the roots of denominator and there is no zeros, and gain factor you have to check, which will be 1. Okay. Please try on your own. Otherwise, I will help you with algebraic form. For algebraic form, let me first this comments. So I will delete one of the form, ZPK form, which I don't want for next. Okay. Any one form is sufficient, but you should know both, because whenever you have a problem, whichever form it is given, you can simply solve it from that form. Okay, so remember here numerator is 1, denominator is 1 minus 6. Numerator is simply 1, denominator is 1, 0, minus 6. If you write simply 1 minus 6, you will go wrong. Let me show you that first. 1 minus 6, then you will get transfer function as 1 by s minus 6, because the highest order is 1, next is minus 6. So s minus 6. If I write the next is 0, that means it is s square is 1, coefficient of s square is 1, now s is 0, then s to the power 0 is minus 6. If I run now, then you'll get s square minus 6 directly. This is how you need to interpret. Now, let us take few problems on block reduction. Now, while reducing the blocks, you should know the techniques of block diagram reduction. The block diagram reduction here is with respect to Laplace domain, not with respect to time domain. That's very important and you need to know. So please use capital letters in all the cases. So here I have input R of s, C of s is my output, intermediate output is x of s for J1 of s, and its input for G2 of s. If I have them in series one after another, I can write it as G1 into G2 of s like this. Now, for example, I can take G1 as 10 divided by s square minus 3s plus 2 and G2 as s plus 1 divided by s square minus 5s plus 6. So in both these cases, what I know that I have already represented these two in transfer function, and if I want to find the series, then I have a built-in function which I will show. First I need to comment the one that I don't want. So I'm going to comment the function h. Okay, now G1 and G2 transfer functions are available. Then what I'm going to do is I'm going to find out new function. I can call it as sys_sir, just for understanding. Sys_sir, that is serial, is equals to series. Okay, then it is sys G1 comma sys G2. Okay, now if I run it, I will get outputs for all these three cases because I have not put semicolon. Okay, yeah, you can check here, you can move it up and down. Okay, the first one is 10 divided by s square minus 3s plus 2. Next one is s plus 1, s square minus 5s plus 6. Now, because of the operation of serial, we get 10s plus 10, s square minus s to the power 4 minus 8s cube plus 23 s square minus 28s plus 12. Please verify the same from manual calculations. Now, we'll go to the parallel. In the parallel, it's very simple, where if you have the two inputs which are going in forward direction and they are added, then you get output, and in that case it simply add instead of multiplying. So that is taken care in the system. So if you know what is G1 and G2, again I will use the same G1 and G2 which I have, so then I'll get the output. So for that, instead of, okay, I'm going to comment this first, series. Okay, and I'll use the same and modify. Instead of series, I call it as parallel, sys_par. So I'll write it as built-in function as parallel. If I use this and run the program, now the one that we got it as series, now we get parallel. Now here you can see sys G1, sys G2, sys parallel. Please verify the same from manual calculations, which I hope you will do. Okay. Now, how to reduce a feedback? Remember here, G1 is forward path gain, H is feedback path gain. That was I was talking about the usage of the names G and H. And G1 I am using and H I am using. Now, this equation you already know from theory, but I am not going to use this. This is a built-in function. Only remember whether the feedback is negative or positive. So based on this, I am going to compute the required output. So for that, first I am going to take a copy of either series or parallel. Then I write feed just for understanding purpose. For built-in function, I need to use feedback. Remember, the feedback has default two parameters, sysg1, sysg2. But apart from sysg2, there is a third optional parameter which you can enter, comma. I can write it as plus or minus based on whether it's a negative feedback or positive feedback. Generally, by default, if I have negative feedback, I don't have to write it. Okay, it computes the feedback of the system and gives. If you have any doubts, please put it in comment section. Thank you for your time.